Okay, before we get started today, I will give you a warning that you definitely need a calculator out. Some of it will be required just using, math, but also on the back we're going to talk about how to input things into your calculator. So whatever calculator you plan to use, and you use most frequently, you need that out today so that you know how to input some of these things into your calculator. We're also doing kind of a disjointed lesson. So this first part is just talking about some angle terms and familiarizing yourself with our Cartesian plane and the angles that are forming on the Cartesian plane. We're going to talk about complementary and supplementary angles, and then on the back we're going to talk about how to input some of those things into your calculator. So first kind of topic of discussion is looking at angles in standard position. Now in trig, we often draw these triangles in different quadrants, and we talk about something called a reference angle, and these angles are formed with specific terminal and initial sides. So our initial side is always, that's a bad drawing. Our initial side is always the same. It's always located on the x-axis going in the positive direction. So we always measure our angles by our initial side and then the terminal side. So at some point I have some terminal side, so I'm going to draw that in quadrant 1. So that's what my terminal side looks like. And the angle that's formed is in between my initial side and my terminal side, and I'm going to call that angle theta. Now that terminal side could end up in any quadrant, so I'm going to draw just a couple different examples of what that would look like. So let's say that my terminal side ended up in quadrant 3. So my initial side is still my x-axis in the positive direction, so my angle that's forming is something that looks like that. Let's say that my terminal side ended up in quadrant 4. So that would be my initial side. If my terminal side ends in quadrant 4, I'd go all the way around till I hit that. Now there is a possibility, so I'm going to draw the same terminal side. We always go counterclockwise around our circle. So this would be really the theta that we're looking at. It'd be this, large angle. However, sometimes we have the same terminal side and we can go counterclockwise, and we measure that by like a negative sign. So this would be some negative theta, not the same one, so this would be some positive version, and if this was say 300 degrees, it wouldn't be negative 300 degrees but instead negative 60 degrees, and we'll talk about more of why that is, and maybe you already know about how to find those coterminal angles, or those angles that kind of share that same terminal side in a little bit and later on. But for now, just know that it's possible, and we always measure it with a negative sign when we go the other way around. So as I'm going around my Cartesian plane, I'm hitting these kind of important angles. So as I hit this angle, if this were my angle that's formed, my angle would be 90 degrees. And if I keep going, now if this were my terminal side and my initial side, it'd be this entire angle here, which is 180. And if my terminal side was the y-axis going down, it'd be 270 degrees. And then I'd be back to, this is 0 degrees, I'd be back to 360 degrees. And you're probably familiar with this from Algebra 2. You did a lot of naming these angles and drawing reference triangles, so this shouldn't be news to you. Now once I start at my initial side and I go all the way around and I end up back at my initial side, I'm going 360 degrees, making one rotation. So we can measure these things also in the number of rotations that we have. Likewise, if I go to my initial side and I go all the way over to 180 degrees, that would only be a half a rotation, because I'm only going halfway around my circle, around my Cartesian plane. 90 degrees, as I'm looking at my whole Cartesian plane, would be a fourth of our circle. So they're all some ratio of the total amount that I'm going around, and the total amount that I have is 360. So these pieces are part of that entire 360. So for example, if I said 50 degrees, that one's a little harder to actually decide how many rotations it would be because it's not like this clear-cut nice number. It's located somewhere in here. So we have to figure out where this would actually be as far as the number of rotations. And we can express it again as some ratio. So I'm only going 50 degrees out of the entire 360 degrees, or if I simplify that, it would be 5/36 of a rotation. And likewise, I'm going to add another box. I could expand this or generalize it to any number of degrees that I have, so n degrees. I could figure out the number of rotations it would be by taking n and divide it by 360. So let's say my angle measurement was 720. If I found out how many rotations that would be, if I did 720 divided by 360, I would get 2. So that means that I would start at my initial side, go one rotation around, and then a second one, and I'd end up right back here in that same spot. Now when that happens, when you end up back into a same spot or they have that same terminal side, that's called a coterminal angle. So if angles share the same terminal side, then they're coterminal. So for example, I'm going to draw two different angles. Let's say that this is my terminal side and this is the angle of my first one. We'll say it's, I don't know, 45 degrees. I could also add another rotation to that, and this could be the angle that's formed. That would be a coterminal angle. Or I could go backwards and get to that angle. So there's lots of ways to get to that same coterminal angle. Or I could go one more rotation again. So to find those coterminal angles, what we do is we add or subtract 360 degrees. And that will give us all the possible, if we keep doing that, it'll give us all the possible coterminal angles. So for example, let's say this is 45 degrees. So 45 degrees and whatever 360 plus 45 is, which is 405 degrees, would be coterminal angles. They're differing by one rotation, but they end in the same spot. So that's part one of the video. Part one of the lesson is figuring out how to name these things, or where, you know, a 200-degree angle would be located. That would be in between 180 and 270, so it'd be in quadrant 3 here. It'd be finding a coterminal angle, that kind of idea. Second part is looking at complementary and supplementary, which you probably remember these terms from algebra or geometry and or algebra 2. Complementary angles are angles that add up to 90 degrees, and supplementary angles are angles that add up to 180. Why this is important is if we look at our Cartesian plane, these are all 90-degree angles that are formed, and these are all 180-degree angles that are being formed. So we deal with this idea of complementary and supplementary a lot when we're dealing with like these angles that are formed in these two different places. So we're going to just do a quick example here, or quick two examples. Example 1 here is something that is complementary because we have this 90-degree angle being formed. So if we're trying to find each angle measurement, we have to take each expression, add them together, and set it equal to 90. So I'd get 5x, negative 10 plus 15 is going to be positive 5. Equals 90. I would subtract 5 from both sides, get 85, and then divide by 5, and I should get, let's see, here's my calculator, 17. So x is 17, I would plug it back in. You could plug it back into both, or you could plug it back into one and then decide to take the supplement or the complement of that angle, and that would give you that. If I plug in 17 here, I should get 41 degrees, which is one of my angles. And I could do 90 minus that or plug it in here. Either way, you should get your second answer of 49 degrees. So those are your two angle measurements for those two spots. Same thing for example 2, except the angle that we're forming is a straight line, which is 180 degrees. These are supplementary angles. So again, I'm going to take my two angles that I see in my diagram, Add them up, set it equal to 180. I'll get 12x plus 31 plus 29, that's 50, 60 equals 180. Subtract 60. Get 120. Divide by 12, and you should get x equals 10. And again, to find the actual angles, I'm going to plug in sub in 10 to x, and I'll get 70 plus 31, which is 101 degrees. Not really accurate for my picture, but that's okay. And then if I plug in 10 to this one, I'll get, you could do it either way, but 50 and 29 will be 79. And you could double check, or I could do 180 minus 101 and also get that 79 degrees. That's part 2, so that should be pretty familiar and pretty straightforward. Part 3 is dealing with this secondary notation called degrees, minutes, and seconds. Now, when we measure angles, a lot of times we have something that is a repeating decimal or some crazy number. So a way to eliminate some of that is to use degrees, minutes, and seconds. It's just a system that we use to measure angles a little bit more precisely. Honestly, the book uses it so often that's why we're actually teaching you how to do this in your calculator. But in general, for this class, you will never be asked to leave your answer in degrees, minutes, seconds on a test or a quiz. The only reason that, again, I'm showing you this is because the book uses it so often, sprinkled out through the entire book, that you need to know how to convert it now. So that way, when we're in chapter 6 and they give you a problem that's in degrees, minutes, seconds, you can know how to deal with that a little bit better. So you can't really see this very well, but here's your degree symbol, and then you have a minute symbol and a second symbol, and these are basically like out of 60, since we have a kind of like clock that we're looking at. These are all in out of 60 as their base. Okay, except for the degrees, just the minutes and the seconds, just like it would be in normal terms. So I have 2 calculators here that I'm going to show you how to do this. The first one is a graphing calculator. So if you have something that looks like this, you're going to just keep watching now, and I'll show you how to do it. But if you don't have a graphing calculator and you have something that looks like this, yes, I stole Mrs. Bosworth's calculator so that I could show you how to do this. If you have one that looks like this, you can just fast forward to the graphing calculator version and skip right to the more scientific, the TI-30X. Okay, so I'll start with the graphing calculator. We're going to convert this into DMS. So first thing I'm going to do is, since I'm converting it to this new form, I'm going to type in my degrees. And then we're going to convert this into DMS. There's an app button here, this purple one, and above it says angle. So we're going to hit second and go to angle and scroll down to 4 and press enter. And I'm going to press enter again, and it'll tell me the degrees, minutes, and seconds that are associated with it. So we should get 52 degrees, 40 seconds, and 48 minutes. Okay. I can also go the other way, and I can go into, given something that was in degrees, minutes, and seconds, convert it back into a decimal approximation. So I'm going to do that now. When I do this, I have to individually do them. So if you'll notice, if I go back to the angles, what we saw when we opened that up was a degrees and a minutes. So we can use that to go backwards. So I'll type in my 78. I'll go to angle, second, and the App Store, and you should get angle. Type in my degrees, and then I'll put in my minutes. So 8 minutes, same place, second angle, scroll down to 2. And then we'll put in 14 seconds. Now, just so you know, there wasn't a seconds button in here. It's actually kind of hidden. So when I type in my 14 here, I have to go all the way to the plus sign, and you'll see the green second symbol. So you have to press the alpha button. Oops, that's the wrong button. Alpha and the plus sign, and you should get the minute symbol there. and you press enter, and then we get a decimal approximation of 78.1372. Now this is why sometimes they use degrees, minutes, and seconds, is because this is something that's not very nice. It doesn't actually end, but this is a nice succinct way to actually represent that angle. It's in a more precise way. So we'll do one more. Again, I'm going to put this in 23, put in my degrees, 6 minutes, put in my minutes, and then 15 seconds. Alpha plus, there we go. And I'll get 23.01042. Okay. And then if I am given something that doesn't have actual degrees and it's something that is smaller than 1 degree, most calculators, if I try to do this, I'll put in my 30 minutes here, it'll give me an error. So instead of just putting it in straight like that, I have to know that there's no degrees above it. So this is smaller than 1 degree. So what I am actually inputting into my calculator is 0 degrees, 30 minutes. So that's all I'll put in. 0, keep pressing the wrong button, 0 degrees, 30 second angle minutes. Oops. 30 minutes. And I can press enter and it'll give me 0.5 degrees. So something smaller than 1 degree. Okay. If you had this calculator, I'm going to show you how to do that. Get stupid. Okay. So again, what we're trying to do is we're going to convert these things that are decimal approximation into a more precise way to measure it. So if I'm going to convert 52.68 degrees into DMS, I'm going to type in 52.68, and then you'll see you have a button here that's under the delete, that is your degrees, minutes, seconds, so you need to press that and scroll on over all the way to DMS, press enter, and then press enter again, and you should get the outputted version of 52 degrees, 40 minutes, and 48 seconds. You can also convert, again, the degrees, minutes, and seconds back to a decimal approximation. So we're going to do that next. So as I'm putting in this value, clear my screen, I'm just have to press this button and press enter to the appropriate one. So 78 degrees, 8, pressing that button again, scrolling over to the minutes, 8 minutes, and then 14, scroll over 2 times to get my seconds. And then press enter and we'll get 78.1372 degrees. Now this is why sometimes we use degrees, minutes, and seconds, because this is a better representation than what I've written here, because we really have 0.1372 repeating, and so this is just an approximation where this is exact. So it can come in handy, but in general we'll just use the decimal approximation if, again, I'll accept that on a test or quiz. We'll do it one more time. So 23 degrees, 6 minutes, and 15, oops, must have pressed the wrong button. 6 minutes and 15 seconds. So we should get 23.1042 degrees. And if you have something, for example 6, if you have something that's smaller than 1 degree, so this is 30 minutes, we don't have any degrees in front of it, if I try to put that into my calculator and go over to 30 minutes, it'll give me an error. So instead, what you should know is that if we don't have any degrees, what we need to input is 0 degrees and then 30 minutes. So 0 degrees, 30 minutes. Oh, missed a 0, 30 minutes. And then I'll get my decimal approximation, which is really 0.5 degrees.